Fluorescent luminaires can indeed be used on arc fault circuit breaker or Psi branch circuits, but there are important considerations to keep in mind. The key lies in the type of ballast used in the luminaire. Electronic ballasts, often called e-ballasts, are generally compatible with Psi's. These ballasts typically generate high-frequency harmonics that don't interfere with the Psi's operation. Traditional magnetic ballasts, on the other hand, can cause problems. These ballasts, when used with lamp holders, often require an additional device to function correctly with Psi's. This device is called an arc suppression module, or ASM, or sometimes an arc fault suppressor, or AFS. The ASM or AFS is installed between the ballast and the lamp. It helps to mitigate the arcing that can occur in fluorescent lamps, preventing nuisance dripping of the Psi. When installing fluorescent luminaires on Psi circuits, there are several crucial requirements to follow. Firstly, always ensure the luminaire is specifically labeled as compatible with Psi's. This labeling indicates that the luminaire has been tested and meets the necessary standards for safe operation on Psi circuits. Secondly, if you're using traditional magnetic ballasts, make sure to install an ASM or AFS according to the manufacturer's instructions. Correct installation is critical for the device to function effectively. Thirdly, follow all National Electrical Code, or NEC, and local electrical codes for proper wiring of the luminaire in the Psi circuit. Proper wiring is essential for safety and to prevent electrical hazards. If you encounter issues with fluorescent luminaires tripping Psi's, there are several potential causes to investigate. Firstly, an incompatible ballast could be the problem. Check the luminaire's ballast type and ensure it's compatible with Psi's. If it's an older magnetic ballast without an ASM or AFS, that's likely the cause. Secondly, a faulty ASM or AFS can also lead to tripping. If you suspect the ASM or AFS is the issue, replace it with a new one. Thirdly, loose connections in the wiring can create arcing and trigger the Psi. Ensure all electrical connections are tight and secure. Fourthly, lamp defects, such as faulty or flickering lamps, can also cause problems. Replace any lamps that are showing signs of wear or malfunction. Finally, unexpected voltage spikes or electrical surges can trigger Psi's. Check for any electrical surges or transients in the system. To assist you in selecting compatible luminaires, here are some examples of Psi-compatible options. Philips Acclaim LED luminaires with e-ballasts are known for their compatibility. Sheet Lighting Sensor Plus LED luminaires are another reliable choice. Eaton Halo LED downlights with e-ballasts are also a good option. For luminaires using ASM or AFS devices, Lithonia Lighting Lithonia LED luminaires with ASM or AFS are worth considering. Acuity brand's Sandal High Bay LED luminaires with ASM or AFS are also a suitable choice for high bay applications. Now let's delve deeper into the technical aspects of Psi's and fluorescent lighting to understand why these considerations are so important. Arc fault circuit interrupters are designed to detect dangerous electrical arcs in a circuit. These arcs can occur due to damaged wiring, loose connections, or faulty appliances. Psi's work by monitoring the current waveform in the circuit. Normal current waveforms are smooth and sinusoidal. However, when an arc occurs, it creates a rapid and erratic change in the current waveform. The Psi detects these changes and quickly trips the circuit breaker, interrupting the flow of electricity and preventing a potential fire. Fluorescent lamps, by their nature, can generate some electrical noise and harmonics in the circuit. Harmonics are multiples of the fundamental frequency of the electrical system, which is typically 60 Hz in the United States. Traditional magnetic ballasts are particularly prone to generating harmonics due to their inductive nature. These harmonics can sometimes mimic the characteristics of an arc fault, causing the Psi to trip unnecessarily. Electronic ballasts, on the other hand, are designed to minimize harmonic distortion. They use electronic components to regulate the current flow to the lamp, resulting in a cleaner and more stable waveform. This makes them more compatible with Psi's. Arc suppression modules and arc fault suppressors work by filtering out the high-frequency noise and harmonics generated by the magnetic ballast. They essentially clean up the electrical signal before it reaches the FSI, preventing false tripping. When selecting an ASM or AFS, it's crucial to choose one that is specifically designed for use with the type of ballast and lamp you are using. Incorrectly matched components can lead to ineffective arc suppression and potential hazards. In addition to the type of ballast and the use of ASM or AFS, proper wiring practices are essential for ensuring compatibility between fluorescent luminaires and FSIs. Loose connections are a common cause of arcing, so it's important to make sure all connections are tight and secure. Use appropriate wire connectors and ensure they are properly installed. Avoid overstripping the wires, as this can expose bare conductors and increase the risk of arcing. When running wires, be careful not to damage the insulation. Damaged insulation can create a path for current to leak, leading to ground faults and arcing. Follow the National Electrical Code, or NEC, guidelines for wire sizing and conduit fill. Overloading circuits can cause excessive heat and increase the risk of insulation breakdown. Consider the location of the fluorescent luminaire when selecting an FSI. FSIs are typically required in bedrooms, living rooms, and other areas where people are likely to be present. However, they may not be necessary in areas such as garages or unfinished basements. Consult your local electrical codes for specific requirements. It's also important to understand the different types of FSIs available. Branch circuit FSIs protect the entire branch circuit, including the wiring and all the devices connected to it. Combination FSIs provide both branch circuit protection and arc fault protection for extension cords and appliances plugged into outlets. Outlet branch circuit FSIs protect only the outlets and the branch circuit. When troubleshooting FSI tripping issues, start by identifying the specific circuit breaker that is tripping. This will help you narrow down the possible causes. Check the load on the circuit to make sure it's not overloaded. An overloaded circuit can cause the FSI to trip, even if there are no arc faults present. Disconnect any appliances or devices that you suspect may be causing the problem. If the FSI stops tripping after disconnecting a particular device, the device is likely the source of the issue. Use a multimeter to check the wiring for continuity and insulation resistance. This can help you identify any damaged wires or loose connections. If you are not comfortable working with electricity, it's best to consult with a qualified electrician. Working with electricity can be dangerous, and it's important to take all necessary safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. By following these guidelines and taking the necessary precautions, you can safely and effectively use fluorescent luminaires on FSI branch circuits. Remember to always consult with a qualified electrician if you have any questions or concerns. The National Electrical Code, or NEC, provides comprehensive guidelines for our electrical installations, including the use of FSIs and fluorescent lighting. It's important to stay up to date with the latest edition of the NEC and to follow all applicable codes and regulations. The NEC Article 210.12 covers arc fault circuit interrupter protection. This section specifies where FSIs are required in dwelling units. The NEC Article 410 covers luminaires, lamp holders, and lamps. This section provides requirements for the installation and wiring of luminaires, including fluorescent luminaires. The NEC Article 410.73 specifically addresses ballast requirements for fluorescent luminaires. This section outlines the requirements for ballast construction, marking, and installation. The NEC Article 410.130 covers the installation of electric discharge lighting systems of 1000 volts or less. This section provides requirements for the wiring, grounding, and protection of fluorescent lighting systems. In addition to the NEC, there may be local electrical codes that apply in your area. These codes may be more restrictive than the NEC, so it's important to check with your local building department to ensure compliance. When installing fluorescent luminaires on FSI circuits, it's also important to consider the energy efficiency of the lighting system. Fluorescent lamps are generally more energy efficient than incandescent lamps, but LED lamps are even more efficient. Consider upgrading to LED luminaires to save energy and reduce your electricity bills. LED luminaires also tend to be more compatible with a size than traditional fluorescent luminaires with magnetic ballasts. They produce less harmonic distortion and are less likely to cause nuisance tripping. When selecting LED luminaires, look for products that are Energy Star certified. Energy Star certified products meet strict energy efficiency guidelines set by the U.S. Environmental Protection Agency. In addition to energy efficiency, consider the light output and color temperature of the fluorescent or LED luminaires you are selecting. Light output is measured in lumens and color temperature is measured in Kelvin. Choose luminaires with a light output and color temperature that are appropriate for the application. For example, warm white light, around 2700 Kelvin to 3000 Kelvin, is often preferred for residential applications, while cool white light, around 4000 Kelvin to 5000 Kelvin, is often preferred for commercial applications. When replacing fluorescent lamps, be sure to dispose of them properly. Fluorescent lamps contain mercury, which is a hazardous material. Check with your local waste management authority for information on how to properly dispose of fluorescent lamps in your area. Some retailers also offer lamp recycling programs. By following these guidelines and taking the necessary precautions, you can safely and effectively use fluorescent and LED luminaires on RFSI branch circuits while also ensuring energy efficiency and environmental responsibility. Always consult with a qualified electrician if you have any questions or concerns, and always follow the National Electrical Code and local electrical codes. Understanding the interaction between fluorescent lighting and arc fault circuit interrupters is key to ensuring a safe and reliable electrical system. Remember the core principles. Firstly, use electronic ballast whenever possible. Secondly, for magnetic ballasts, install a properly rated ASM or AFS. Thirdly, ensure all wiring is tight and secure. Fourthly, replace any faulty lamps promptly. And fifthly, consult with a qualified electrician when in doubt. These steps will help minimize nuisance tripping and ensure the effective operation of your RFSI protection. By paying attention to these details, you can create a well-lit and safe environment for your home or business. The goal is to balance the benefits of fluorescent lighting with the critical safety features provided by arc fault circuit interrupters.